Bueno, pues nuevamente muchísimas gracias por continuar con nosotros en este emocionante cuarto día de Congreso, el cual ha probado ser de una calidad muy alta, con temas bastante profundos y no solamente interesantes, sino que también con un alto grado de información e innovación en cuanto a las nuevas tecnologías, como acabamos de escuchar ahorita en la plática pasada del arquitecto Miguel Ángel, en el BIM. Surya, Sunand, be very welcome to Universidad Autónoma Metropolitana. We are eager to hear you, but let me introduce you in Spanish, please. Bien, un momento. El tema que vamos a escuchar a continuación es la creación de un programa de ingeniería centrado en las personas, utilizando procesos impulsados por el diseño. Nuestro invitado es Sunand Bhattacharya. Él es un arquitecto de aprendizaje con especialización en enseñanza y el aprendizaje basados en el diseño. Se desempeña actualmente como asesor de consultoría para varios establecimientos educativos, como la oficina del director del Colegio de Boston, el distrito escolar de Waltham, así como profesor en el Franklin College of Engineering y el Massachusetts College of Art. Bueno, es muy importante para él que antes de regresar al mundo académico, Sunand fue el estratega de aprendizaje global de Autodesk. Para aquellos que estén interesados en todo lo del BIM, pues él es una de las personas en las que hay que apoyarnos. Liderando su equipo de Learning Futures, y en este puesto fue globalmente responsable de la estrategia, la gestión y la evangelización en la defensa de la influencia futura de Autodesk como marca, como empresa, pero en la educación de ingeniería y STEAM relacionada con el diseño. Antes de Autodesk, Sunand fue el socio principal y cofundador de Arjuna Learning Designs, una firma especializada en la creación de objetos de aprendizaje interactivos, algo que acabamos de ver con el arquitecto Miguel, en este caso para mejorar la calidad de la enseñanza y el aprendizaje para las editoriales de marcas reconocidas. También es profesor titular de diseño industrial y ha ocupado puestos ejecutivos en la Universidad del Sur de Illinois. Sunand ha recibido el Premio de Excelencia Innovadora en Enseñanza, Aprendizaje y Tecnología de la Conferencia Internacional sobre Enseñanza y Aprendizaje Universitarios. El mensaje que tiene para nosotros en este día es que con base en los complejos problemas que enfrenta ahora el planeta y el cambio sísmico que está teniendo lugar en la educación superior, ¿cómo podemos tejer de manera significativa y holística la ciencia, la tecnología y las artes liberales para hacer del mundo un lugar mejor? En esta presentación, Sunand nos va a compartir cómo las estrategias impulsadas por el diseño se utilizan en todo el campus del Boston College o del Colegio de Boston para producir futuros graduados que estarán bien posicionados para abordar los principales desafíos que enfrenta el planeta y que tienen dimensiones científicas. Finalmente, el objetivo del día de hoy es demostrar cómo los procesos de pensamiento impulsados por el diseño están siendo adoptados por la educación superior en la creación de programas de futuro y socialmente relevantes, como la próxima ingeniería centrada en el ser humano del Colegio de Boston. Sunand, it's a real pleasure to have you here. So, to not take more time from your wisdom, excuse me, please go ahead, your audience.
Okay, thank you very much. That sounded very exotic. I didn't understand much, but I think I got the gist of what you were saying. Let me do this. Can you see my screen, my full screen?
Yes, we do.
Okay, perfect. Good morning, good afternoon over here, everybody. And thanks for the very kind introduction. I have packed quite a few things. So on Monday, when I attended the session when Hector Silva was presenting, he had some really thought-provoking points that he had brought to the table. And as I started thinking about it, I figured I need to talk about two things. One is where design-driven processes are taking us in the grand scheme of things and how we have applied it at Boston College to build a human-centered engineering program using these processes. We've also incorporated design in engineering. So I'll talk a little bit about that. So on that note, I'm going to start. We've already been through my introduction. So there are two things that are kind of embodying the spirit of this conference, from what I understand, Claudio. That what design, vision, strategy, structure, practices facilitate the urgently needed social economic transformation. Number two is how can the current situation be used to generate new opportunities for design project development as a strategy for the incoming future. So I'm going to stay within the context of these things and offer what I'm saying. Design in our context, there are two kinds. There's the big D, the capital D that we know of, which is your industrial designer, graphic designer, etc. And then there's the small d, which is coming up, which is the process. And that small d is getting democratized. By that I mean other professions are actually taking design process and running with it. Medicine, engineering, mental health, business. So Harvard Business School has made design thinking an integral part. So it is something that is racing ahead. So when we look at who we are, Boston College is a private Jesuit liberal arts university. It's a Research One Institute. It was founded in 1863. And it's based on Ignatius principles. And if you look at any American university campus, you can actually draw a perspective grid over it. And you'll see all these buildings that are there, the different departments. And what happens is these departments become little silos of their own. And often it leads to very monocular vision and not that much of collaboration among the disciplines. And yet, when a student is coming in, they're taking classes from business, from building to building, and it's left to them in their heads to put things together. Some do a good job, others struggle with it. So this was something that was recognized by Boston College quite some time back. In 2013, they launched a strategic vision planning session. And in 2014, they realized they needed help from outside. So they hired the design firm Continuum, which is located here in Boston, to help align divergent perspectives and guide to redefine BC's core curriculum for the 21st century. So that's where the relationship with design started at BC. BC was probably one of the first universities to bring a design firm as a consultant into it and allocate resources for that for a year. That led to a couple of things. One is introduction to something called complex problems and enduring questions, which is multidisciplinary in nature as the foundation. The second part is in 2017, Phil Schiller, the CMO of Apple, Chief Marketing Officer of Apple, gave $25 million to start something called the Schiller Institute for Integrated Science and Society for Health, Energy, and Environment for undergraduate research. We also got resources to start engineering for the very first time. Boston College did not have engineering. And that meant that it was a clean slate for us to begin with. That also led to Boston College embracing design and innovation-driven strategies into its mix. So now, moving forward in 2021, we'll be starting the engineering program. But there are two things that we're handling right now. One is that led to how can we create a hub at the center of the university, a well-equipped hub that anybody could go in and work using the labs through applied research and collaborative experiences. How can we introduce new programs like engineering? And then how can we, in the long run, catalyze a design-driven culture at the university? So if you look at it, this is under construction right now. And there'll be all these different amenities over here, from maker spaces to design thinking, ideation labs, etc. And the engineering school department will also be located here. So when we look at things, stepping back, we have two things on our hands right now. Number one is to prepare for implementing engineering. But just putting engineering in isolation is probably the easy thing to do, but that wouldn't serve us any purpose. It'll be yet another silo. It is very important for us to look at how we create a culture, catalyze a culture of design and innovation across BC, so that when we do put in human engineering, it'll be well received and more interdisciplinary in nature. So that success was very important for us in terms of how we bring this, how we implement. So in 2017, this decision was taken to offer a general engineering program. But then we started questioning ourselves. Given where we are in the Boston area, we have 5,871 students graduating from within a 2-mile driving radius every year. Boston is kind of unusual. We have Boston, Cambridge, and the neighboring areas, and some of the world's best institutions are located here. Out of them, 6 of them are Research One institutes, like MIT, Harvard, and all that stuff. So if we start engineering for the very first time, and this young person is going to be graduating in 2025, what is her world going to be like? That's the question we need to ask ourselves. And that kind of gets into our design approach, the user, the who. So when she graduates, along with these students graduating from Brown, MIT, Harvard, Tufts, Olin, Boston University, Northeastern, etc., she will be facing competition. So what will she be bringing to the world? She'll be bringing engineering capabilities, of course, but one of the things that Boston College takes pride in is its Jesuit-based liberal arts education. So if we can effectively create a student who can tell stories, who can collaborate across disciplines, who can practice integrated collaboration, exercise social and ethical responsibility, think globally, practice human-centered design, so that the types of industries in 2025, when you look at it, things are changing. There's automation, robotics, machine learning, Internet of Things, constructioneering, we just heard about BIM, service industries, NGOs, startups coming up. So how will she be contributing to these companies is what will make us make a sound program and an experience for education. So we kind of stepped back and started looking at what is it that we need to do, and to do it really well. We need to look at who our students are, what are the competition that I showed you, but most importantly, trends. What are the trends dictating? What are the future needs of technology, the mindset of the student, the culture, the socioeconomic horizon, industry, and employer? So I'm going to focus right now in this little red circle to go through some of these trends that we have studied, and then how we have kind of incorporated that into our new engineering program that we're developing. So when we look at design-driven education and practices, change is necessary. It is not, as Hector pointed out also, it is a necessity that is happening and will continue to happen. It is not an option anymore. So the question to ourselves is, are we in higher education ready to embrace and accept shifting mindsets of the next generation, meaning the who, the user? Are we ready to embrace new trends in innovation? Are we ready to embrace effects of technological advancements which are changing? And are we going to design responsibly for a better planet and society? So when we look at these trends, first of all, our language is changing, the vocabulary. When we look at it, all these different terms have become very popular these days. User-centric design, inclusive design, design thinking, design swarms that Surya will talk about tomorrow, collaboration, empathy. So when you look at all these things, there's a shift. When we look at history, things have evolved from learning through apprenticeship, where design started pre-20th century, getting into the industrial assembly, the DIY, do-it-yourself, entrepreneurs, maker communities. And then with the current trend that's going on, maker entrepreneurs from a young age, from school, people are starting to put things together with 3D printers. And then the next generation, the future, is next generation of maker entrepreneurs will increasingly focus their attention on to socially relevant innovation. What does that mean? That means right now people are experimenting with things that are creating a lot of junk also. Just because people have 3D printers, that doesn't mean, they're designing responsibly. There are things going to the landfill. But that is shifting as well. People are trying to do meaningful work. So as you get into looking at trends, the first cardinal rule of design thinking is your end user. How can we design with the end user, the who? And what is their mindset? How is that changing? So when we look at that, let me start with a little story here. This is young Jacob. Jacob is no longer young anymore. He's at Worcester Polytechnic. But this is when he was 14. Jacob has attention deficit disorder. And he needs to hold something, to fidget with something, to pay attention. And he struggled with it for quite a while. So his father was very encouraging. He had some tools at home. And he taught Jacob to use digital tools, to innovate, and to come up with solutions. Long story short, fast forward, Jacob, through 3D printing and all, created something called GY rings. He actually used Fusion from Autodesk. So my background being part of Autodesk, it was helpful for me to get this story together. Jacob lives also locally over here, close to me. He then worked with his father and became not just a designer of the fidget widget, as he called it. He also became an entrepreneur. He was able to manufacture, get a factory in China to work and create these things called GY rings, packaged it, created the whole thing. And now it's being sold in Target store, Barnes and Noble, etc. The point being, he's no longer just a designer of a solution. He has looked at the entire process. He was just 14. So when you have the Jacobs of the world coming in to universities, the question to ask ourselves is, are we ready? Are we really ready to cater to Jacob? And when you look at the population, Generation Z, that we're talking about today, Generation Z has a different mindset. Generation Z is quite different from myself. Their learning universe, as you can see, they're in the center. The educator is on the side, who's facilitating things. They're also constantly on texting. They are instant messaging. They are using the internet to most effectively. Very honestly, I don't know how they balance so many things at the same time. When I look at my children doing that, it boggles my mind. So these children coming up who are raised on a digital diet, their world is going to be different. And this is not just in America or in the developed countries. It's happening in other parts of the world. Here's something in India where students have mobile phones and they're wanting to become creative innovators, solution seekers. So this has spread. I'm sure it's spread very much in Latin America as well, or it's spreading. Augusta Foundation has reached 12 million children, 250,000 teachers, to bring this whole design-driven teaching method. High schools are innovating like product design, like what I did in college. So when you see students like Kate or Muhammad, who's sitting over here, who met with Obama, and now Kate is a student at Brown University and RISD. She's doing a double major between engineering and design. That student will get bored if we don't keep up with curriculum and teachers, kind of engaging the students. So when we look at the raw material, the students coming in, Generation Z, the future students in a university, what are they expecting? This was a study I had initiated when I was at Autodesk through Illinois Institute of Technology. They want their experience to be easy to develop and transfer skills. They want it to be engaging and in the moment, practice studio culture everywhere, integrate with their work process, use technology when they need to and want to, and be familiar with them. If it's complex, they get bored, they move on. So there are a lot of these mindsets that are there. The second part of it is their attitudes are quite different from people like myself who are gray-haired and bald. They want to be empowered. They probably don't go into the depth as much, but they go breadth-wise things. And they are everything from a designer to an artist to a scientist to an engineer. They're being raised that way. So the demarcations between disciplines are blurring, which is great, which is actually a very exciting thing for us to happen, and we should capitalize and leverage that. Also looking at trends of emerging technologies and innovation. So what's happening over there? When you look at technological advancements and the delta factor it's causing, there are so many different things happening. There's VR, AR, there's Internet of Things, there's robotics, there's additive and hybrid manufacturing, factory of the future, cloud collaboration, reality capture, generative design, machine learning, smart cities. That is quite a different menu of emerging technologies over the traditional things that were already there of that engineers went through. So how do you teach, create a program where the students are well versed with these technologies as well as some of the traditional technologies? So we have to look at the way we teach. Here is something very interesting. We were talking about BIM. Here's a 57-story building that was built in China in 19 days. This is a very multidisciplinary effort which has civil engineers, earthquake specialists, humanists, sustainability people, architects, engineers, all working together to create something that was unthinkable several years ago. 19 days, 57-story, which is earthquake-proof, and it's a green building. So that's the trend that's happening, speed. Machine learning is also teaching us a lot of things in terms of how materials can be optimized. This is just a concept aircraft that Airbus did with Autodesk. But that leads us to something called machine learning and generative design, in which the machine is getting the variables and generating forms. So at Autodesk, what we did was we put sensors on the chassis of a car, many sensors, and then it was driven through the Mojave Desert. And the motion that the chassis encountered, all the variables were collected through the sensors. And then that was fed to a software that then led to creating optimized chassis. So when you look at this, what is happening from an engineering point of view? You have fed the variables, and the machine is generating different kinds of forms and shapes that weigh less, that are structurally strong, that use less material. So when you start looking at this trend, how will designers and engineers function in the future? And what are we doing to impart that kind of education for them to take decisions? And then how does that lead to the manufacture of lightweight cars that are sustainable? Tesla has used a lot of Autodesk software in developing its solutions. So the other piece, looking at trends, is attitudes that are affecting design-related education. So one thing that is different from my time, where we did not have these amenities, the internet, 3D printers, or robotics clubs and all in school. It was a different world. Today, everyone has capabilities to design, whether they go through formal design education, their innate capabilities to innovate is alive very much, and the new emerging technologies are actually helping them design better. So that's a student who's coming in to our design schools with expectations. We not only need to just meet their expectations adequately, we need to exceed their expectations. We need to do better than that, so that when they go out, they're well equipped with a changing world. That's where we'll be doing the right thing in terms of developing a pedagogy, an institution, and an experience. So you can see how students, these young people, are innovating. And one of the other pieces that's taking place is the amazing complexity. In my time, on the left side, we were given a brief, we came up with a solution. On the right side, there are many other factors that are being taken into consideration to design objects existing in endless complex systems connected to countless other objects, environments, and people. So that's kind of the model that these students will be facing. And then look at the studio over here. There's real-time collaboration like we are doing right now, and COVID has actually done a very good job in forcing us to capitalize on the technology that has always been there. Instant access, meaning we're getting feedback very quickly, and seamless integration between disciplines. So this is not just industrial designers working, there are other professions also working with them. And then today's classroom, it's a different structure. It's not just engineering or design. We have classes where 3 different disciplines or 4 different disciplines or many more disciplines are working together to solve a problem. That's where the radical collaboration is coming in. And then when you look at this example over here, here is something that typically an electronics engineer or an electrical engineer would be using to design a product. So an industrial designer would do the body, the electronics engineer would be doing the circuit, and then somebody else would be designing the machine. Today, with software like Fusion in the cloud, all of these can be done in a distributed way simultaneously. So that we are cutting down on the time from idea to manufacture to prototype. That's the new future. I mean, that is the future that's now. So at the end of the day, what are we asking for? Making, thinking, and communicating, these 3 abilities becoming core of design education so that young students can design faster, work anywhere, share with anyone, and do all these things responsibly. That is the key over here. So having been through this exercise, we then started applying it to implementing and building our new program, engineering. Yes? Did you say something? So the questions we asked ourselves is, how does one introduce change into an ongoing successful traditional academic setup? How does one introduce and integrate technology-driven culture into liberal arts environments? And mind you, these places are already functioning. So you're bringing in a new kind of change, a shift. How can we catalyze a design-driven culture into liberal arts environment, into in an agile manner, quickly? So the other questions we started asking ourselves for engineering is, why engineering? What type of engineering? Why now? And how would it be developed? So now that we were equipped with that knowledge about students and their mindset, we kind of sat back and then we started looking at, well, we need to do something else across campus to catalyze a culture of design and innovation across BC. So if something is going to start in 2021, excuse me, I think someone needs to mute. So given where we are at BC, by the time 2021 comes around, we want to bring about design-driven innovation and a science and technology-driven attitude. So when you look at that and stand back, what are we doing about it? We are trying to see.
Excuse me, Sunand, please, por favor, apague los micrófonos.
Thank you. So, what are we doing? We're trying to seed an enduring culture of design thinking across BC, and here's what we have done right now. And actually, Surya, your speaker tomorrow, is going to be expanding on design swarms and hackathons. Then thinking courses. We've started a course which has become extremely popular, which shows that your students are hungry. They want to do this thing. We are starting a making and fabrication lab, speaker series, prototype labs, design clubs. Students are very on their own going and creating significant design-related clubs. There's a design thinking, an innovation club, DTI. There's a make BC student clubs, and all these have 100 to 200 to 300 students already in it. So what will be the pathway for a student going to engineering? We want the student to be going through and taking all these into incorporating all these capabilities for emerging technologies, but we also want other students of liberal arts. You could be a student of drama, music, painting, philosophy, physics, chemistry, and on a campus, you should be able to get these design-related experiences so that by the time you graduate, you are well equipped for the world. So one of the things we have done is through the design swarms that Surya will be talking about, is in the class we have this, and he'll be expanding on it, this gaming canvas, which captures the entire design process, the analysis of the who, the user, and how that journey goes on all the way to a solution. It's become quite a popular tool that we have been using, and we have been asking students about how, and they've been participating in how our future is going to be baked as far as engineering and other initiatives are concerned. The student participation, listening to the student, capturing their viewpoints has been very important for us in terms of applying our design process and creating a new program. In the past, we wouldn't do that. We would just get a few professors together, put something together, and launch a program. It's quite different. There's been a lot of support from the leadership, from the administration, and they kind of understand the importance that design-related processes plays in catalyzing this culture. So we're not moving away from what we do at BC. We have a strong liberal arts foundation. We are adding a layer of design-driven initiatives on top of that, which we hope will lead to more interdisciplinary collaboration for science and society, and ultimately help create new programs like engineering. So these are the scaffolding steps that we have incorporated. And looking at the engineering program now, the specific, good on time, okay. When we look at employers, for example, and if you look at this particular graph by the Future of Jobs report, the World Economic Forum, you'll see the investments are going in over here. 85% investment in companies is on data analytics. So what can we do for engineering and design students, first of all, to understand data and use those effectively? When you look at things like Internet of Things, machine learning, the R&D of many corporations are investing heavily on that side. 3D printing is 41%. It's passé. It's kind of almost here. It's here, not only here. It's here, and it's kind of the sizzle is kind of settling. So this is what's happening on the employer side. When you also look at what kind of people they will want in the future, and what they want today, on the right side you'll see they want people to be complex problem solvers, critical thinkers. They want them to exercise creativity, people management, emotional intelligence, and service-oriented, can negotiate, and have cognitive flexibility. In the middle is what we're trying to do with Boston College, the liberal arts education. But going back to what Hector was saying the other day, this is over and above the design, being a good designer, the design skills that he was talking about. That has to be also coupled with this. Being that and these two things working together and acquiring these two projects is what we are trying to fulfill. So what type of engineering? So that whole study led to the conclusion that we wanted to build a human-centered engineering that will be built on the Jesuit liberal arts principle, that is design-driven and focused on social impact. So when you look at this particular diagram over here, we have the rigor of engineering in the middle core, engineering core. And around it, we have surrounded liberal arts studies, and then design and systems thinking is kind of enabling and facilitating the education model. So when you look at these other pieces, we're trying to weave through it the human-centeredness throughout the program. Themes like health, energy, and environment, problem-based approach, behavior integrated, applied, inter, and transdisciplinary pedagogy, concentrations, reflections, ethics. Ethics is a very important piece. We need to be able, these students to be able to think of unintended consequences of their actions, whether they're engineers or designers. And then we have used this, this is not a very important slide, it just shows you the process that we have been incorporating to launch this program. And there have been many people involved in this. The building is under construction right now, and it will open this spring, as you can see. So, in closing, what do these shifts mean for us in education? It's very important for us to, as educators, as students, and as administration, the leadership, to understand that these shifts we need to contend with, not just because it's an option, it's a necessity. Above all, these cannot happen without thinking. We need to be graduating students who can design responsibly, human-centered or life-centered design for a better planet, designing for social justice, and focusing on unintended consequences. COVID is a good example of how it's being handled and what is happening through not taking into account unintended consequences. Number two, radical collaboration by design for the future of making and learning. Collaboration is the kernel, the center, in terms of the actionable items that students need to take out. We need radical collaboration if we are to truly address the nexus of design, make, use, infinite computing, digital manufacturing, and Internet of Things, places, and media. This is a very different kind of designer that we need to be graduating into the world. And the Generation Z is already ready with a lot of these things. So it's not a hard task in that way. And third thing is, we have some great opportunities and challenges in front of us, given 2020 and what is the lessons we have learned. I think this has opened, Claudia, you were talking about this whole conference model online. It's really a great model, and we are connecting much better than in a crowded conference. Number four, radical collaboration by design is the future of making and learning, and it's here. It's not something that we are preparing for. So we need to be working backwards and to see what is going to be needed 2026, 2027, 2030, and work backwards as we look at curriculum and new programs. So on that note, I will stop the Today Tomorrow threaded and open the floor for questions.
Excuse me, Sunand. Very interesting chat. I would like to see if there are questions from the public. Si por favor tienen preguntas, que los vayan subiendo. And in the meantime, well, to congratulate you, because what you are showing us today is not just a presentation on needs or expectations, but a plan. And I think that's something that we designers need to endure, the fact of planning ahead. Your vision on the needs and to try to predict the needs for a student and the how do you say, the amount of knowledge that he has to deliver by then is very deep and very new in a way that it's a real critic for nowadays design program implementations, but at the same time, of course, to be a critic, you are putting on the table a proposal that is very interesting. So please, if you have any questions, please, you can speak it loudly. Alguien que tenga una pregunta, por favor, lo puede hacer de viva voz.
Tenemos unas preguntas aquí en el chat, si me permites.
Permiso, pero hay dos preguntas en el chat.
Hay dos
por favor.
aquí. Sunand.
Yes.
Do you think that other disciplines being able to apply design methodologies in their fields strengthens or, on the contrary, weakens design job opportunities?
So, a couple of answers for that, Doctor. The reason I had two approaches, catalyzing a culture as well as launching a program, those two go hand in hand. So what has happened is when Surya and I started this new program called Innovation Through Design Thinking, it was a small class of 25. Now we have waiting lists, and this is spreading to hundreds of students through various different courses. And when we look at the roster and the disciplines, there are people coming in from philosophy, from theology, from English literature, from physics, chemistry, economics, and they're participating in this because we don't have engineering as yet. So that is number one. So that shows you a trend from students. But that's also showing us students are a lot more active and wanting to learn and chart their pathway than we sometimes as faculty or administration do to respond to them. And the thing is, if we don't respond to them, they will move us. They will affect us. I mean, that's what students are doing. So that's one part. The other part to your question is, we do need to seed certain things, like plant certain seeds, so that when people see those as examples, then they can kind of build on those. So there's some resources that we use, both outside in jobs as well as inside within BC through activities. Did that answer your question?
Thank you, Sunand.
Well,
And Ariel Lagunas asks you, hello and good morning. Do you believe that transdisciplinarity will replace specialization? What will the degrees of the future look like?
Can you repeat that question, please?
Do you believe that transdisciplinarity will replace specialization?
Great question.
That's one. And the other is, what will the degrees of the future look like?
Great question. Let me answer those two. One is, I think interdisciplinary and transdisciplinary abilities being woven into programs that have specialization is a must. So let's say I'm an applied physics major, or I'm an engineering major. I should still learn how to be a better communicator and working with other disciplines and using those models. And the curriculum needs to incorporate that. That means faculty and departments need to provide those experiences. That means their internships, or bringing speakers in, or showing them case studies, going abroad, working with people, not for people. So that is an absolute necessity. So that the specializations also incorporate a foundation, which is what liberal arts education truly tries to incorporate. So what we're trying to do is to design thinking and processes to strengthen that. The second part of it is, when you look at what employers are asking for, there are two kinds. There are ones that are looking for very immediate people who have the skills to start working on it. And, if you're hiring a doctor, the doctor has to be medically qualified to be able to do what they're supposed to do. The same thing with an architect or an engineer. But they're also banking on those other skills that I showed you. So, and then the third thing is, I think a lot of us depend on degrees, but a lot of the just-in-time short abilities courses and credentials, micro-credentials, are becoming extremely popular. And universities need to kind of embrace those things as well, in my opinion. So I hope I answered the question.
Yeah, thank you a lot, Sunand. And I mean, in one way to summarize your exposition could be that you are proposing that college or traditional higher end education has to really have a blend between hard skills and soft skills, because when you talk about storytelling, collaboration across disciplines, communication or interface integration, you are talking about soft skills. And when I listened to Raul Silva on last Tuesday, he was talking about this Unite program to fill the blanks and on soft skills that are given away, or I mean just left aside by the college education. And just yesterday, Rosemary Martinez, a graphic designer, she was speaking also about the same kind of issues. You need to know how to sell, you know, need to talk to the consumers, to have to learn how to approach them in order to really have this interconnectivity and the consumer or a human being participation. So is that one way to really address the idea?
Definitely. So I would use another term also in addition to what you just said, Claudio, is seamless integration. So
Seamless.
what happens is, on a big university, students go from building to building, department to department. They're supposed to take a set of courses, you know, along with their, let's say, engineering or design core. They're supposed to take general education in, let's say, English, math, physics. And it's like a checklist. But what does not happen that effectively, or is left to chance, is how they integrate those things together. Why did I study English? Or why did I study language? Why am I studying Spanish? You know, Spanish is a requirement in a lot of universities in America. And why am I studying philosophy or chemistry? So what we have done in the new engineering curriculum is every semester, we have put a 1 credit hour equivalent time for reflection. So it's not just you introduce that right up front in first year and we forget about it and then student graduates. That because it's a repeat thing. So you have to make it a habit. So seamlessly integrating it into your habit. And that's where reflection kind of makes you sit, think back, look at it from a distance to see why did I study what I studied? What kind of skills am I studying? And it may not have an immediate payback, but I should be able to connect the dots. So that seamless integration, Claudio, is, I think, a very important piece, is helping the students connect the dots.
Okay, I have another comment, but before I would like to translate the following question. To what level of participation do you believe is this collaborative work and participative work and multidisciplinary work useful or adequate?
I didn't quite get that question, sorry.
Okay. To what level of participation do you believe it is adequate, the collaborative, participative, and multidisciplinary working?
Very important. In fact, it should not be an afterthought. It should be an objective that is of prime importance. Because sometimes what happens is we go in our labs or shops and all and design something and then kind of backfill some of these things into it. But if you follow the design process or the design thinking process, the 6 steps where the empathy model and all those things come up, those are integral to the system. So practicing that together and practicing that collaboration in an interdisciplinary, with an interdisciplinary team, as would happen in real life in a corporation or industry, is something that is of great importance.
Well, based on this question you just answered, I would like to ask you, how did you came about, and most of it, how did you come to an agreement with all the faculties around in the city or the college city to make that hub and to make it happen? Because I guess it meant a lot of discussions, a lot of negotiations. So it would be a nice example of this collaboration integration, please.
So in all honesty, I was also lucky in some ways. When administration and leadership is invested in it, it makes a huge difference because it's a top-down and bottom-up thing. So there are faculty, there are students, there are faculty who are interested, but we also had support from the provost's office. I'm part of the provost's office. So when the leadership is invested in it and the two work together, that works. Now, there are many other institutions who would love to change their existing engineering program to be taking into account this whole design process, collaborative process, etc. But they cannot bring about changes because in academia in America, and I think in other places as well, bringing about change to an existing structure, getting agreement with faculty is more complicated than the Congress over here. So I was lucky that so leadership, try to find that person at the leadership level, the first or second level, who believes in this is very important. The second part of it is showing examples. Go for small wins, not big ones. Sometimes we wait for the actual creating the whole monument, the silver bullet. Well, do little things that can show the pathway to that, but show the results, have metrics that you can measure and demonstrate. That makes a huge difference. And we did that.
Okay. Is there anyone who would like to have a comment, to make a comment or a question, even lively, by your own voice? ¿Alguien quisiera hacer alguna participación, comentario en vivo? Okay, well, in that case, I would like to keep on commenting with you, especially about that last graph.
There's actually, Claudia, there's a question over here, a comment from Melina. She said, do you think that other disciplines being able to apply design methodologies in their field strengths, or on the contrary, weakens the design job opportunities? So let's take that question for a second. Melina, when I talked about the big D and the little d, the big D was the big design job opportunities. And that only gets strengthened when other disciplines, take on the design processes and the methodology. Because once they see that, their ability to collaborate with you, that wall breaks. So I would say that strengthens the design job opportunities, because as a designer, you have those added skills of putting together a solution that they don't have. So I hope I answered your question, but I think I look at it in a very positive way.
That's very interesting. Is another question? Oh, here it is. No, it's the same one. It came to me a little bit later. I was about to ask you about your last graph, where you were talking about this kind of a Boston College chart.
Yeah.
With the empathy, the human-centered design, the driven innovation, this design-driven innovation versus science and technology-driven innovation. And you have already scheduled these 3 steps on 3 years to get to a point. And I do believe it's quite a short time. So what kind of a plan or what kind of an organization do you have behind the curtains in order to be so precise?
Right. So again, I have had really good support from various. So there was one piece which gets into the whole so we have architects, and the building piece was one piece, the whole infrastructure, putting it together. So I have a director of design innovations who's working on that. Being in Boston, we also have MIT and other places over here, so that we can kind of move forward with getting consultants. So we've had deans and presidents from Harvard, MIT, and all these others. So we use that to kind of get validation. And then internally, we've had, we started the hiring process earlier. So COVID actually helped us a lot because we were able to kind of hurry through, get faculty and chair and all in place. So that is going on right now. And then what we've done is create a blueprint for the curriculum so that every faculty member that we hire does not have to sit and start from scratch. We want them to be fulfilling a certain ethos that we have, a certain belief. So we have to hire the right kind of faculty member as they start working on it. So it's a multivariable problem. That graph that you saw, it's several things and that we're working together simultaneously. I'm kind of juggling all those things.
Okay, well, Sunand, our time is gone. I want to thank you on behalf of Universidad Autónoma Metropolitana because you have not just been here to give you a lecture on design and programming, but you have brought us the best. The latest that is happening up there in Boston College. So we are pretty thankful about that effort from your side.
Thank you very much.